Algebra 1 is a prerequisite to this class, and we're going to be doing quite a bit of it. So here we go. We'll note first with this diagram that we have vertical angles. These two angles are across from each other. They share a vertex. They're going to be congruent. So what we're saying is that whatever we get for 78 is what this is going to be as well. So this is actually 78 degrees. However, we need to find out what the value of x is. So if two angles are congruent, we can set them equal to each other. So you have 78 is equal to 5x minus 2. We want to get the x by itself. If there's any addition or subtraction, we take care of that first. To move this minus 2 to the other side, we do the opposite of what we see, so it'll be a plus 2. And then we divide both sides by 5 because they're currently being multiplied by 5. And I get that the value of x is equal to 16. Now, what we could do with this value, right, we were asked to get x. Now we should get the angle. We know the angle should be 78 because of vertical angles. But let's show the math. So I would plug into this x, this 16. So I have 5, remember use parentheses, times 16 minus 2. 5 times 16 is going to be 80. 80 minus 2 is going to be 78 degrees. So we have proven that this is 70 degrees. We know that this was 70 degrees and also this is 70 degrees. They're vertical angles. It makes sense. We should not do the same thing with this next problem. This next problem is not about vertical angles. We're not looking at this angle and this angle. We're looking at this angle and this angle right here. These two angles form a line, therefore they're a linear pair. And if they are a linear pair, they're supplementary. And if two angles are supplementary, they add up to 180 degrees. We notice two like terms, so I can add these together and I get 7x plus 19 equals 180. We subtract 19 from both sides. Remember, we do the subtractions and additions first. Currently, this x is being multiplied by 7. I only want x. I don't want the 7x. So I divide both sides by 7. This gives me an x value of 23. Now, we found the x value. Nice. We need to find the angles. So this x value is 23 degrees. That's straight and to the point. That's just the way it is. There's no math to do. But with this other angle, which is an obtuse angle, the other angle that forms a linear pair, I have to plug in the 23. So that's 6 times 23 plus 19. We do order of operations. It's 138 plus 19. And if we add those both up, we're going to go ahead and get 157 degrees. So we get that this acute angle is 23, and then this obtuse angle right here is 157 degrees. I leave it to you to check if these are supplementary, right? If you were to add this 157 to this 23 degrees, would I get 180 degrees? It would be worth your while to check if that's the case. Okay, we're going to get beefier. Note the placement of the letter. So I have an x here, I have an x here, I have a y here. So we are solving for two different variables, x and y. We're also finding the measurements of the angles that they represent. And furthermore, we have to be careful with how we set this up. Because we can't just say, we could say that these are a linear pair, and we will at some point. But if we start off with, don't write this down, but if we start off with this right now, we won't be able to solve for anything because I have only one equation and I have two variables. This is not going to work out for us nicely. May I suggest, since this has an x and this has an x, let's take care of those two first. Now, these two angle relationships are vertical. And so we know the vertical angles are congruent. And if vertical angles are congruent, then they're equal to each other. So, Ms. Shover, sometimes you set them up and you add them equal to 180. Sometimes you don't. You just make them equal to each other. How do you know? It depends on where they're located. If I'm looking at angles across from each other, I set them equal to each other. If I'm using angles that are next to each other that form a line, then they add up and equal to 180. In this case, I'm working with two angles that are across from each other, and so they're equal to each other. I'm going to move this 4x to this side. I get 2x equals 16, and I get x equals to 4. JK, x equals 8. Okay, so this is 8. What we can do with this is we can go ahead and already begin to find out what these other angles are. So for example, 6x. Well, if I plug in an 8 here, 6 times 8, that's equal to 48 degrees. So this angle right here is 48 degrees, right? We were asked to find the x. We found the x. Now we got to find the angles. If we were to plug in 8 into here, I get 4 times 8 plus 16. Order of operations is 4 times 8 is 32 plus 16. And then that gives me another 48 degrees. Wow, so this is also 48 degrees. Fascinating. They must be vertical angles that are congruent. Why did you plug in an 8, Mr. Over? Because x is 8. And if x is 8, wherever I see an x, I plug in an 8. So do we plug in an 8 for y, Mr. Over? No, that's a y. How do we find y? Let's go ahead and do that. We know that 6x and 11y are a linear pair. Now, we don't have to actually say 6x. We could save ourselves a problem if you want and just already use 48 because I know that this angle is 48 degrees. If you want to use 6x, you could. It's just extra math. So if you want to do the 6x plus 11y is equal to 180 because they're a linear pair and linear pairs are supplementary, we can do that. However, we already found out that 6x is equal to 48 degrees. So I replace it back in. All I have to do now is solve for y. I'm going to subtract 48 from both sides. And then divide both sides by 11. I get y is equal to 12. But that's the value of y. I want the angle. So if I plug in 12 into this y, I have 11 times 12. That's 132 degrees. So this is 132 degrees right here. So after doing all that algebra, we're pretty much saying this is 48 degrees, this is 48 degrees, and this is 132 degrees. Now, spoiler alert, if this is 132 degrees, nobody asked, but we're going to say it anyway, that's also 132 degrees. I'll leave it up to you as an exercise to show that these are supplementary. They add up to 180. I'm going to help set up this problem, and I'm going to do half of it, but I'm totally going to trust you to do the other half. I will give you the answers, of course, so you can double check to make sure you know what you're doing. But Algebra 1 skills, pre-algebra skills actually, is what we're doing, pre-algebra, are necessary for your success in this class. So may I suggest, if you're struggling right now, it's not because of the geometry probably, it's probably because of the pre-algebra. So consider your pre-algebra skills. Okay, let's do this. Let's make some observations. So in the last problem, we had x's across from each other, and that's why we set up vertical angles. Okay. In this case, we have the x's are actually neighbors. They're touching. So that's they're adjacent. And these are supplementary because they form a line. So this is a linear pair as well. So I know these two are going to add up to 180. We also note that on this side we have the y and the y, and they're not across from each other. They're neighbors. They're sharing a fence. They are adjacent. They form a line. That's a linear pair. So what we have going on here, I'll go ahead and do the orange pair. We have these two are going to be supplementary. They form a line. So I have 4x plus 10 plus 3x minus 5 equals 180. They're not equal to each other. See, if they were across from each other like in this problem, they would be set equal to each other. We're not dealing with equals. If you wanted to set up an equal that makes no sense, we could. We could, for example, set up 2y plus 28 is equal to 3x minus 5. That's very much true. But we won't be able to solve it because I have two different letters. So we're trying to make the math easier for you by allowing you to just work on letters that you are the same. Okay? So we're going to work on the two x's. They're both orange. They're both a linear pair. They're supplementary. So that's why they're equal to 180. If we go ahead and work with this, we have these. This is a like term with this. And this is a like term with this. So if I combine these, 4x and 3x is 7x. And then positive 10 minus 5 is a positive 5. And that's still equal to 180. We subtract 5 from both sides. And I lost my, what am I doing here? That's an x, not a 3. You're tripping over. Okay, so I subtract 5 from both sides.
Could you say that again, please?
And I get 175. You're tripping over. And then we divide both sides by 7 to get the x by itself. And I get a value of x is equal to 25. Now, all we did was find the x.
You're tripping over.
So remember, problems are going to either ask you to find the x or find the y or also find the angle. We found the x. X is not the angle. None of these angles up here are 25 degrees. All of these are more than 25 degrees. So this is not a degree answer. This is a variable, an x. To get the angles, we go ahead and plug this 25 into this x value here and this x value here. So for example, in the first case, I have 4 times 25 plus 10, right? It was 4x plus 10, but I substituted the x 25 in. I get 100 plus 10, and that's 110 degrees. So what we're saying is that this is 110 degrees. Doing this other angle right here, 3x minus 5, that's 325 minus 5. We replace that 25 in for the x. That's 75 minus 5 is 70 degrees. So we find that this is 70 degrees. Hint, will you note that 110 plus 70 is 180? They are supplementary. This checks out. So far what we've done is we found the value of x. We found this angle right here. We proved that this is a 110 degree angle, and we proved this is a 70 degree angle. Your job is going to now be to find out the y value. So you're going to do the same thing pretty much, and then plug them in to get the angle measurements.
Could you say that again, please?
So I want to suggest and ask you to pause the video at this point and set up what you need for this statement right here to find the value of y and then show how to get these two angles right here.
You're tripping over.
Pause. So here's the setup. Of course, it's not equal to each other. It's equal to 180 because it's a linear pair. Here's some algebra. The value of y is 21. We now present the two angles.
You're tripping over.
Now, of course, the 21 was plugged into both y values from these given angles. What's awesome is what we expect to happen, right? We know that these two angles are across from each other, and they happen to be the same measurement, 70 degrees. And the same thing with these two angles that are across from each other. They're vertical angles, and vertical angles are congruent. So it would stand to reason that these would also be equal to each other. So we have 70 degrees from across each other, 110 degrees across from each other, and any two pairs of adjacent angles would add up to 180, no matter which two pair you pick. For your summary, what is true about vertical angles and what is true about a linear pair?